So we're talking about polynomial behavior.
So wait, this is gonna go in. This is like a video.
That's right now. It's recording. Okay, so we had either a bounce, a wiggle, or a cross that happened with these. So I want you to right now first look through all the ones that you had that crossed. What do you notice about the exponents?
They're one.
They're all one.
They're all 1. So to get a cross, we need a 1 for the exponent. To get a wiggle, can someone start giving me the different exponents you had for wiggles?
5.
Okay. What's another?
3. They're all odd.
They're odd, but what are they excluding?
1, 2.
Not 1.
I mean, I see.
So they're odd, but they're not going to be 1. Does that make sense?
Yes.
Because 1 has a different rule. And then bounces. Give me some of the exponents we had for bounces.
2,
2,
4, 13,
6. So you said that they are all even. So, like I said, I just wanted to kind of sum up the rules that hopefully came through in the activity yesterday. And so if we have a bounce, the exponent that creates that on the term that created that 0 is going to be even. If we have a wiggle, the exponent on that term that created that is odd. If we have a cross, the exponent on that term is 1. So right now we are going from the factor to come up with the zeros in the behavior, but we can actually go the other way, and we'll do that tomorrow in class. So now let's talk about the last 4 columns.
The what?
The last 4 columns on your worksheet. And so that's talking about the end behavior and the degree. So how did we find the degree to begin with?
You add up the exponents.
You add up all the exponents. If there's not an exponent on that term, what's it considered?
0.
1.
Oh, really? Oh, yeah.
If there's not an exponent on the term, it's considered 1. That's what threw them off a lot last period. So, like if I have x times x plus 3 to the 4th times x minus 1 to the 5th, I would do 1 plus 4 plus 5, and my degree would be 10th. Okay.
What does the degree determine?
It determines the behavior of the ends, and it's going to also determine how many times we should see it cross, or some rules on that. We're not there yet, but it's going to determine a lot of different little steps. And so let's go ahead and let's look at all the ones that had even for your degree. So look for all your even degrees. What do you notice about as we approach y from both the right and left?
Their signs are plus.
The signs are plus.
Signs are both the same.
Their signs are both the same is really more where I'm going with this. So it's either going to be positive. It's going to end up looking kind of like a smiley face with some weird stuff happening in between. We don't know what this middle section is, but we know the 2 ends are both going to be going up, kind of like a field glow. If it is negative, the 2 ends are going to be going down. We don't know what's happening in here, but we know the 2 ends are both going down. So these are both going to, y is approaching negative infinity on both of these, and on these, y is approaching positive infinity. So if it's even, we know it's a field goal, and it's either going up or it's both ends are going down. So, the first one that we have exposure to with odd degree polynomials is what you learned back in 8th grade, 7th grade when you started learning linear terms. So a line is the first of the polynomials you learned with odd pattern. So let's talk about these. Which of these two, the right or left, has a positive slope?
The left.
The left. So this has a positive slope. This has a negative slope. Well, the same idea, it's not really slope, but that same idea of the leading coefficient is kind of taking the place of that slope for telling us our end behaviors. So if we have odd, they're going to be opposite. One's going to go up, one's going to go down. Just like you worked with slope. So if you're positive, you start low, go high. If you're negative, you start high, go low. And we always read a graph from left to right. And so that's the reason I always start with the left-hand side. So we're starting low, going high for positive, and starting high, going low for negative. And so if I was to just like in the other ones, we don't know what's happening in here. So the left and the right, we're going to go ahead and identify as y is going to approach what on the left on this one.
Just an infinity.
So the left-hand side is, so it'll be negative infinity. The right-hand side is positive infinity. On the other side, on the negative one, the left is going to go to, so we're looking at this side. Is it going to positive or negative?
Negative.
This corner, looking on the negative.
Oh, it's going to positive.
So it's going to go to positive. The right
Going to negative.
And so on odd behavior, we are going to see the same idea as a linear, which y'all all should hopefully by this point be able to do positive and negative slopes. So that may help you. You will see me when I'm trying to think things through and more complex, start to use my hands. And actually make my body the graph. And the behaviors. And so we're going to do that here in a minute as a class. But, so if our leading coefficient is positive and it's odd, they're going to go in opposite directions, but our left side is going to be the negative infinity, the right side is going to be the positive.